Hi, here at the OpenStack Summit, I'm here to talk about the OpenStack and the WAN. My name is Sig Luft. I'm CTO and co-founder of a company called Ciaris. We're developing a OpenStack-based cloud platform that's designed to orchestrate the WAN as well as a variety of clouds. We are currently in trials with 2 service providers, and we're looking to go to product next year. I wanted to start the discussion with a sort of a common, well-understood framework. So if we look at this illustration here on the projector, we have a well-known picture of OpenStack where you have compute, networking, storage, and ultimately it's all there for applications to be deployed on the cloud. Part of OpenStack is to provide management and a dashboard, orchestration, but it's the applications that are separately running inside these clouds that is what's important. As we go to a scenario where there's 2 clouds, it's not a problem. You have 2 applications running in 2 different clouds and life is good. However, when we start to look at one application running across 2 clouds, things get a little bit more challenging. Distributed or federated credentials is something that's coming in Juno, but there are other issues that the application is going to have to start to think about when it gets distributed. When we look at connecting these clouds and the intercloud WAN, there's a class of problem that multiple data centers or clouds can be used to address, but there's real requirements on the network. So things like 3-tier apps, backup, and latency-sensitive applications can't rely on just over-the-top internet-type connectivity. And as a result, these types of applications have to have WAN connectivity in place. Coming from a cloud perspective, one would think that you could have APIs that would just simply orchestrate this and all would be good. The reality is in most cases, these types of network connections can take months to be provisioned. So if you're thinking about cloud and auto provisioning, the intercloud WAN is really a little bit far behind. There are some steps improving, but it's still quite a challenging problem. Then if we take this picture and say, I have an application and I want it to be deployed not just in an OpenStack environment, but in a variety of public clouds, frankly, you're going to be in a lot of trouble to try and get this done. The reality is, though, this is not an unreasonable request. Applications should be able to take advantage of all these resources, and we think that this is probably a very reasonable use case for the application. But the reality is, to get it done today, you're going to end up with an application that's probably 80% management and orchestration software inside it, and maybe 20% application. So this is a problem that we think can be addressed and should be addressed. So we take a look at this problem from sort of a holistic view. There's some well-known constructs, cloud, WAN, and at the end of the day, they're there to service applications. And as we've mentioned, there's a type of application or a use case which we think is an emerging problem in cloud, which is really more mission-critical applications going to the cloud, where connectivity is important. So here we show the applications, and we show that the connectivity is being driven right through into the WAN. And so you have 2 areas, both cloud and WAN orchestration, used to make this happen. When we take a look at the state of the world, you've got OpenStack, VMware, a variety of orchestration tools, and at the same time you have some orchestration tools in the WAN. The SDN is sort of emerging. You'd think that WAN, having been around for decades, would be far more advanced than cloud, but the reality is cloud is actually ahead of the game. The role that we're playing at Ciaris is really to straddle the line between both the orchestration of the WAN and orchestration of the cloud. And in doing so, we try to fill in the gaps and basically make it work. We want to make the applications do what they want to do. And we do this with an OpenStack veneer. Our system looks to the applications in the virtual data centers like OpenStack. It is OpenStack. We do make some extensions that we would like to start to propose into the community, But one of them is to both orchestrate the multiple clouds. The other is to orchestrate the WAN as part of this whole exercise. When we look at this picture, we also think that there's a use case that is very sensible, and that is for the clouds to be leveraging more than just the private footprint, but going into the public environment. And because we're focused on both the connectivity and the clouds themselves, we've been working on ways in which to leverage the direct connect type services. So from a cloud point of view, in many cases you may want to burst into a public cloud for a week or two. But again, from a networking point of view, these types of things take months and months of planning. With our solution, we make it possible to not only spin up the cloud, but also spin up the network at the same time. So if you have a cloud and a network for the week, and they both get torn down at the end of it. The focus of our product is to expand this circle donut to include more public and private cloud footprints. And today we're working towards Azure. We're working on SoftLayer and other public cloud footprints. We take a look at our architecture, and if you think back to the original slides that we showed, we have a fair amount of stuff on this picture to think about. At the top, we have the standard OpenStack APIs. And the way a user of our system sees the platform is through OpenStack. Inside our system, you can come down and you can call Nova, Cinder, Neutron, etc. And you can build yourself a data center. Where OpenStack defines APIs, typically you have drivers that will come down and will be deployed into an underlying hardware. What we're doing with our system and with what we call the Cloud Visor is instead of having drivers that map into hardware, we have drivers that map into what we call underclouds. The underclouds can be a variety of data centers, either running OpenStack, running VMware, or even public clouds. And so from a tenant point of view, we come in through our interface and down into the underlying cloud. From a networking point of view, we are developing what we call WAN as a service. And again, it's something that we think can be have some value to the community. Fundamentally, when you think about the WAN, right now you have Neutron extensions that point outside of the data center, but there's nothing that actually manages what's in between. So you have the data center on the left pointing right, the data center on the right pointing left, and you hope that they meet in the middle. So with the WAN component of our solution, we're trying to provide visibility and management of that component of the problem. In our system, the underlying clouds, we don't really care about the hardware. We don't really care about the orchestration. Certainly have a preference to OpenStack. But we allow essentially any type of underlying footprint to be orchestrated through our layer. And to the applications that are running above us, as far as they're concerned, they're running on OpenStack. On the cloud side, or the intercloud WAN piece, we have no particular opinion of the type of hardware that is used to connect these data centers. We can work with layer 2 technologies, layer 3 technologies, and are currently doing so with our service provider customers. And this becomes orchestrated through the WAN piece, giving more of a holistic view of the problem. Again, thinking back to the original narrative, the application can be deployed now in either of these clouds or both of these clouds and can request connectivity between the two, and that should be the simple world that they operate in. Finally, our target customer is network service providers. We believe service providers have a very strong play in the cloud space. They have a lot of assets and a lot of strength that I think are important to the enterprise customer who's consuming cloud. If you look at this illustration on the left, we have the enterprise customers who already have a relationship with the network service provider. Their connectivity comes from the service provider. Now, many enterprises are looking at going to the cloud, if only just to get out of the business of buying new servers every 18 months. And so if you're looking to take your data center and move it into the cloud, there's a few options you have. One is to go all the way out to the public cloud, such as Amazon or Rackspace, Or another option is to go to your service provider. From purely a regionality or regional perspective, the closest point and probably the best connectivity point to be placed is in the service provider if they offer cloud footprint. And this is really a target for our customers to manage the data centers, cloud data centers the service provider offers, as well as the public clouds. So in many cases you want a variety of footprints, whether or not it's bursting into the public clouds or using them for other purposes, as well as the network itself that provides connectivity between all of these footprints. So what our platform does is it allows the service provider to offer a single solution that provides OpenStack to both their cloud assets as well as public assets, and also can orchestrate the connectivity between the two. And in doing so, we provide a single platform for cloud offerings that address multiple cloud footprints. And that's the end of our tech talk. Thank you very much.